இங்கே எஸ்ஆர் அந்த எஸ்ஆர்
அது போடுங்க சார். சரி சார் சார் மேடம் ரிங் மேடம் நான் ரிங் பண்ணுறேன்.
Very good morning to everyone present here. It is a great privilege to welcome you all to the public viva examination of Mrs. Rajeswari Immanuel, who will be presenting her research on the topic automated classification and resilience of persons with stress using deep EEG network. We are honored to have with us today our esteemed guest, Dean, Faculty of Engineering and Technology, Director of Academics, Vice Principal Academics, Vice Principal Examinations, DRCC's Chairperson and Head of the Department Computer Science and Engineering, Head of the Department Computer Science and Engineering Emerging Technologies, Head of the Department Electronics and Communication Engineering, Head of the Department Mechanical Engineering, Research Coordinator, faculty members from various departments, research scholars, technical staff and students. We extend a special welcome to our external examiners for today's examination. Dr. A. Kandasamy Sir, a highly esteemed professor in the Department of Mathematical and Computational Sciences at NIT Karnataka. He has been a cornerstone of research and education at NIT Karnataka since 1991, with a PhD in Applied Mathematics from IIT Bombay and postdoctoral experience in Computational Fluid Dynamics from Chuo University, Tokyo, Japan. He has completed 8 PhD scholars and he is currently guiding 2 scholars. His academic contributions include 46 referred journal publications and numerous conference presentations. In addition, he has served as a visiting professor at Asian Institute of Technology, Bangkok, deputed by the Government of India. And he is an expert member of National Board of Accreditation. We are truly honored to have you, sir. Dr. G. Geeta Ma'am, an associate professor in the Department of Information Science and Technology at Anna University, Chennai. She completed her PhD at Anna University in 2013, Masters at Satyabama Institute of Science and Technology, and Bachelor's at the Government College of Engineering, Europe. With nearly 2 decades of teaching and research experience, she has published more than 130 papers in reputed journals. She has been recognized with the Best Teacher Award twice in 2005 and 2013 and was recently honored as Best Professor by the Progress Global Award in 2023. She has successfully completed 8 PhD scholars and she is currently guiding 3 scholars. It is a privilege to have you, ma'am. Now, I would like to introduce the research scholar, Mrs. Rajeswari Immanuel. She is a full-time scholar, research scholar in the Department of Computer Science and Engineering at SRM Institute of Science and Technology, Vadapalani campus. She has joined the PhD program in July 2021. Mrs. Rajeswari holds a master's degree in Computer Science and Engineering from the University of Mumbai and bachelor's degree from the Anna University, Chennai. She has 13 years of teaching experience. She is a very dedicated and hardworking student and confident that she will excel in today's examination. Wishing Mrs. Rajeswari Immanuel the very best for her viva voice examination.
I'm Rajeswari Immanuel, full-time research scholar from Computer Science SRM Vadapalani. This is my topic, automated classification and resilience of person with stress using EEG signal under the guidance of Dr. SKB Sangeeta, Assistant Professor, Department of Computer Science and Engineering, SRM Vadapalani. My DRCC member, Dr. Yes, Prasanna Devi ma'am, Head and Professor, Department of Computer Science and Engineering, SRM Vadapalani. My DC members are Dr. B. Vaidyanathan, Assistant Professor, Department of ECE, NIT, Delhi, Dr. D. Sriram Kumar, Professor, Department of ECE, NIT, Trichy, Expert Member, Dr. M. Selvaraj, Professor, Department of ECE, IIIT DEM, Agenda for today is, these are the topic I'm going to cover: introduction, motivation, research gap, and literature survey, objective, research contribution, publication, future work, and conclusion. These are the coursework I have completed under the guidance of PC members. Introduction. Emotion is a reaction of mind and body together. Any emotion originates from brain. Recognizing an emotion of a human, it is a need of the heart, because emotion intelligence plays a big role in the industry now. Stress is also an emotion which produces or which causes many diseases. It should be handled. Early detection of a stress will help us prevent the disease, and we can save people. Importance of the stress, because due to stress there are a lot of diseases are produced, and because of that the death rate is also more. This is a WHO page where it is talking about millions of loss in a year in the US due to the people who caused with stress. So I have given the link. What is EEG signal? EEG signals are nothing but electroencephalography signals. What is it actually? Our brain is made of millions of neurons together. When we sleep, even when we talk, eat, do some activity, it produces a little amount of electricity which can be captured with the help of the sensor or the helmet. So it can be captured, and that can be used for identifying the emotion. It is a primary source of human reaction, and it is less focused because it is noisy, non-linear and non-stationary in nature, and it gives high accuracy for emotion identification. The motivation behind this stress, as I told you earlier, after the lockdown, people started using a lot of gadgets, people started working from home a lot. So the stress level has increased a lot in every people. So that can be addressed, and EEG is less focused because it is because of its complex nature, and healthcare industry also changed a lot. Previously, we'll visit the doctor. Nowadays, we can take online consultation from the doctor. That is also an motivation. And in research, LLM, emotion can be used with LLMs such as ChatGPT. And early detection will prevent disease. So the literature survey of deep learning research in emotion detection. There are 4 different inputs are given. First one is audio. Second one is tweet done by the patients. And third is the Third is the dictionary taken from the children in the China during the COVID. And fourth one is a voice to text conversion. All this identify the stress, and these are the papers. Identification of emotion using DNN neural network with EEG signal. So here the first paper talks about the multimodal model which uses EEG signal and audio video data also. In the second paper, reinforcement is used with DNN model, and there are benchmark data sets are also used here. And in the third paper, it captures the dynamic spatial data of the signal, and with that emotion is identified. In the fourth paper, the feature selection method is used to extract the feature, and it is used with 3 algorithms: LSTM, RNN and GRU. Next one is emotion identification using RNN with EEG signals. Here there are first paper is using LSTM, and in the with the real-time data of 10 people. In the second paper, the benchmark data set is used. In the third paper, hybrid CNN plus LSTM framework is used, and in the fourth paper, LSTM, RNN and GU is used. Last one, emotion identification using CNN neural network with EEG. So the first paper extracts the various features from EEG signal, and the accuracy obtained is 90% and 93% for deep data set. In the second paper, the CNN is used, and 3D emotional model is identified. So arousal balance is identified here. In the third paper, all the 3D model, the same output is obtained, 92% is obtained. In the fourth paper, the post syndrome, after a disease, what is the stress trauma is identified. The research gap, there is a lack in the real-time data collection for a large group of people, and pre-processing of the same is a bit difficult. And breadth of the feature selection method to identify the important features for emotion identification. And there is a requirement of the best classifier to identify the emotion in deep learning framework with a larger data set. For automated emotion classification, there is a need for the best features to be extracted that can be mapped to the emotions. As me and my guide were searching doing the survey, we came across, we wanted to find any real-time project or any online funded project is going on. We fortunately came across a project which is being done under UK. This project says that out of 10,000 people, only one doctor is available in UK for stress management. So they have come up with a online treatment method where they can wear helmet, and the EEG signal is continuously recorded, and it can be used for the treatment of them. The research objective 1, to collect and pre-process the real-time data to obtain the required data set for emotion identification. Second one, to identify a better feature selection method for emotion identification. And to third one is to develop an automated deep EEG framework that can deliver high accuracy for stress management for the resilience of human with the real-time data. These are the different types of inputs can be given to the emotion identification. EEG signal, ECG signal, skin response, and microvascular blood volume increase, respiratory rate, skin temperature, heart rate, eye movement, muscle movement, gestures like facial reaction, body language that can also be identified. So, but among them we are choosing EEG signal. Why? Because it's a brain signal, it is non-invasive and portable. It originates from the brain, and the emotion is also originating from brain. It is a direct measure of the brain activity, and it gives high accuracy for the emotion identification. Objective 1, to collect and pre-process the real-time data. When we come to EEG signal, this is the there are different types of frequency bands. These are the frequency bands: delta, theta, alpha, beta, and gamma. Delta, we have the little electricity. As I told you earlier, there's a little electricity is produced during even the sleep, when we sleep. So that is a delta. And other activities, gamma is a really active state, and when we are conscious, this amount of electricity is produced. The structure of brain. The brain is divided into 4 parts, 4 lobes: temporal, and parietal and occipital and frontal. Actually, the frontal is the front part of the brain which is responsible for the human emotion. Whatever emotion we develop, it comes from the frontal part of the brain. Other parts are responsible for the other activity like sensory, vision, memory, other things. Next. I have obtained ethical committee approval from the Panimalar Medical College Hospital and Research Center. This is the proof for the same. The preparation and the collection of data. We have collected the data from 35 healthy individuals, 17 male and 18 female. We have used emotive epoch helmet for the data collection. It is 14 sensor, 14 channels, and the data is collected in the morning. We have taken consent form from them, and we have selected the particular channels like there is a location for placing the sensor. So we have chosen the particular sensors where it actually gives a higher accuracy for emotional identification. We have used the double banana montage method. It is a method for retrieving the data. I have taken 1 week training in the SIMS hospital for the EEG data collection. This is the consent form we have collected from the subjects before the test has been conducted. Data collection, we played a video stimuli before the subjects. 40 different videos for 1 minute have been played, and a break of 20 seconds, and it is positive and negative emotion videos are played. The monitor is placed before and the earphone is given for the higher accuracy. These two are the positive and negative emotion stimuli list. The video recorded for 1 minute, 20 seconds in break. Even the neutral state is also recorded. 1280 seconds for each subject we have recorded. 40 videos into 4 segments, 160 label sessions. The bandpass filter is used for 4 to 40 Hz. Only the relevant data is taken. The data beyond that is irrelevant, so we have not taken it. And we have used Z-score normalization for normalizing the data. This is the flow chart for the pre-processing. Each subject, each video has been passed through, and each minute, and it is calculated. 1 minute is divided into 5 parts. First 20 seconds is discarded because it may have a carry forward of the previous emotion. Only after the 20th second we have taken, and it is divided into 4 segments, 10 each. This is the binary classification. Video stimuli is shown for the subject. Video recording is, EEG recording is done. Pre-processing is done. It is given to the classifier, and whether the person is stressed or not is classified. The binary classifier, the name of the binary classifier is gated recurrent neural unit emotion identifier. There is a input layer, and there is a GRU layer where the dropout is 0.2, and hidden layer, 18 layers are there, and the output layer where the output is update in the binary classification whether the person is stressed or not, and the optimizer used here is Adam optimizer. These are the parameters, and we have tuned the parameters very finely to obtain the maximum output or the enhanced output from the classifier. Before. This is the data description. We have taken 3 data sets, 2 online data which are the benchmark data set. Everybody use this data set for emotion identification using EEG signal, and the third data set is our real-time data set which we have collected, and this is publicly available in the GitHub. This is the comparison of the model with the benchmark data set with raw data. The maximum accuracy obtained is 70%. This is the benchmark comparison with benchmark with pre-processed data. The accuracy obtained is 82%. This is the overall model comparison. This is for the existing model DNN, CNN, LSTM and GRUEI, which is the proposed model. The summary of the first objective is the subject is exposed to the stimuli which produces the emotion, and it is captured, and the data collection is done with the pre-consent form, and then pre-processing is done to remove the noisy data, and then segment of 10 seconds for each window size is fixed to 10 seconds, and the classification is done with a binary classification whether the person is stressed or not. With raw data it's 70% accuracy, and pre-processed data it is 82%. These are the papers for the first objective. First paper is the SCI paper. Second one is conference, which is indexed in the Springer. Objective 2, to identify a better feature selection method for emotion using EEG. There are different features we are going to retrieve from the EEG signal: power feature, statistics, and factor dimension, entropy, wavelength, and to total it is 420 features. This is the feature selection process where each 10 second video data has been passed, and it is separately we have used different methods to retrieve the features. For the statistical feature, it is 84 features are obtained. Mean, standard deviation and other things are given. 14 channels, that means 14 sensor into 6 statistics gives 84 features. And these are the formulas for them. And with this, we have obtained the features. For the power feature, we have removed the delta because it does not give any emotion related data, and we have used Welch method to calculate the power spectrum density, and then we have identified differential asymptotic and rational asymptotic, and we have calculated the complexity of the EEG signal also, which contributes to 168 feature. Other 3 features are given here, where EEG signal is considered as a geometric figure, and 3 methods are used, contributing to the 42 features. And for entropy, 5 entropies are used for 70 features are obtained, and in the wavelength it is 4 bands into 14 channels contributes to 56. This is an ensemble learner where we have used CNN plus LSTM to classify multi-class emotion. The raw signal is passed to the pre-processing, and then feature extraction is done. We do extract 420 features, and it is given to the ensemble learner which has LSTM and CNN, and different emotions are identified. 3 different emotions are identified. The input layer, the explanation of the same input layer, then there is a feature extraction method, then there is an ensemble learning, CNN layer, where 1D convolution layer is used, LSTM, which captures the temporal data of the EEG fully connected layer, and there is an output layer where 3 different emotions are given. This is the architecture diagram for the same. This is the hyperparameter tuning where we have the different hyperparameter. These are the ranges we have used, and finally we have set to these ranges where the optimum output is obtained. And results without feature extraction method, it is 85% obtained with the proposed model. With feature extraction, it is 88.11, which is there is an increase of 3% in the accuracy. This is a confusion matrix for all the models. This is a comparison of the multi-class emotion detection method. The summary of objective 2, 5 different emotions are detected, and out of that 420 features are extracted, and the ensemble learning is used to identify 3 emotions, and the accuracy obtained with feature extraction is 88%, and without feature extraction is 85%. These are the publications. First one is a conference, and it is published in the spring, and second one is a Scopus Index paper. Objective 3, to develop an automated deep EEG framework that can deliver a high accuracy for stress recognition for resilience of human. Representation of emotion can be of in a 3D model: valence, arousal and dominance. Valence is nothing but a representation of the quality or the pleasantness of the emotion. It ranges from unpleasant to pleasant, or low valence to high valence. Arousal is a representation of excitement of the emotion, calm to excited, like low arousal to high arousal. And dominance is a degree of control over the emotion, ranging from no control to high control. And the model is classified with the 3-dimensional model. This is a representation of the emotion, alpha, beta and gamma, and low arousal and high arousal, low arousal and high arousal, and low variance and high variance. Feature selection method. Feature selection method play a very important role in the development of a neural network, where we can create a subset of the subset of features from existing set of data. It is the goal of the feature selection method is to improve the performance of the deep learning model by reducing the dimension of the input data with retaining the information. This is the proposed algorithm, where the standardization of data happens. Dimension is reduced using PCA. Then there is a principal components is calculated. Then between class scatter matrix and within class scatter matrix is identified, and a new set of variable is created with PCA, principal component and the discriminant component. And after that, top 100 new set of new set of features are developed that is related to each other, and that is given as an input to the extracted feature to PCA, LDA and the proposed model. So top features are given as an input to the classifier transformer, and the 5 different emotions are identified. This is the complete architecture of the transformer model, proposed transformer model, where data acquisition, pre-processing, feature extraction, feature selection and feature classification. This is the layer, input layer, feature extraction layer, where 420 features are given input, and then feature selection where 100 features are identified, then transformer layer which has a four layers, and then feed forward network, then there is an output layer which identifies five different emotions. This is a parameter, and we are set to these values to give higher accuracy. This is for valence before using enhanced feature selection method, valence and arousal. This is dominance. And after the feature selection, the comparison of feature selection method, PCA, LA and the proposed model, top from the ascending order. First we have given top 20 features, then top 40 features, and 60, 80 and 100. To the understanding, when you give 100 more feature, the accuracy is more. It is up to 95%. This is the prediction time for the different models and different models, different emotions, different feature types, 5 different feature types. The comparison of the accuracy of different models, the different models, 2D model and 3D model, these are the features. They say it is accurate for emotion identification. These are the classifiers used, and these are the number of channels and the window time and the accuracy uptime. The proposed model performs better for the real-time data. And how emotion is calculated, the p-value is calculated. These are the 5 different emotions we are identifying. These values are the EEG signals we have taken. When we pass through the neural network, this is how it is uptime. W0 is a bias value, W1 to Wn is the weight, X1 is the input. And this is a statistical result. T-test is conducted for the identifying which feature is performing best for the emotion. So we can see there is a 2-pair test is conducted. This test is nothing but identifying whether there is any significant change in the mean of 2 features. So for the first valence, we have 10 set of tests. Between each we have done like 5 feature types we are having. So we have done, and the end of the results is null hypothesis is set. Null hypothesis says that there is no difference among the classification results obtained with different types. That means whatever feature type you are using, the result is same for the classification. If the P is greater than 0.05, the null hypothesis is accepted, else null hypothesis is rejected. But to our notice, statistical feature has p-value less than 0.05. That means null hypothesis is rejected, and there is a significant difference in the classification with statistical feature. And the next one is power feature. And this is the rating scale from 0 to 1. The different emotions will be rated. This is a classification table, constraint table. 4 frequency band we have used: alpha, beta, theta and gamma. With these values, p values, we differentiate different emotion, 5 different emotion, and then we classify whether the person is stressed or not. The real-time validation of the proposed model, we have validated our work with a doctor. His name is Dr. S. Harunan, MD. He is a chief civil surgeon. He is a professor of neurology, retired Government Stanley Medical College Hospital. He is currently Professor and HOD of Department of Neurology, SRM Medical College and Research Center, Patambaltu. So what we have done, we have taken the EEG signal, pre-process, feature extraction is done, then feature selection is done, then we have given to the model, proposed model, classification is done, and we show the result to him. Next. This is the letter has been provided, acknowledgement provided by him, saying that the model is valid and it is good working. This is the doctor validation. This is first column is the classification of the model, and second column is the classification. Last column is the classification of the doctor, and there is a slight difference in the classification in one or two people. That's how it is producing 95% accuracy. And a summary of the objective 3. Emotion is classified based on the three-dimensional emotional model. 3 feature selection methods are used. Enhanced feature selection outperform the other feature selection method. Out of 420 features, a new set of 100 features are selected, and transformer model is used. 95% accuracy is obtained. Top 100 feature gives a higher accuracy than 80, 60, 40 and 20. The prediction time is less when we use the proposed model, and comparing all the feature, statistical feature performs better than other feature for the emotion. Our feature performs next. These are the papers. First one is a Scopus paper, second one is a SCI paper, and third one is a conference, and there's a paper patent we have published on the same topic. Next. These are the research contribution. Real-time data is collected with the help of the EEG recorder from 35 healthy people, and video stimuli is played for them to record their emotion. Placement of electrode on the scalp plays a very crucial role to retrieve the right information for emotion, and identifying the particular channel and the brain lobe plays an important role for the emotion identification. Enhanced feature selection method is designed for the feature selection, and significant features are obtained from them, and performance of EFSM performs better than other models, and a 3D model is used for the transformer, the real-time data which classify the arousal, valence and dominance. The new set of features are using multi-class classification. Prediction time is also less, and the proposed model identifies statistical feature performs better than other 4. And this proposed model is validated by a neurologist with the real-time data. Application where and all this research can be applied is monitoring healthcare condition, and it can be human-machine interaction, marketing and advertisement, neurofeedback, and emotional intelligence using LLM model. This comes under the SDG goal 3, where good health and well-being. And this is the conclusion. The EEG signal originates from the brain, and it is the best source to use EEG for identifying emotion. And the real-time data is collected, and the real-time data is compared with the 2 benchmark data set, DEEP and SEED, and the GRUEI outperforms the other models, and the accuracy obtained with the raw data is 70%, and the pre-processed data is 82%, and the pre-processed data is extracted. Pre-processed data is used for feature extraction, and 420 features are extracted 5 different feature types are identified, and ensemble learning is used with LSTM and CNN with higher accuracy of 88%, and without feature extraction it is 85%. The enhanced feature selection method is for the feature selection method it works better, and top under feature gives a higher accuracy, and statistic feature performs better. In the future work, we would like to work with the children of age group 10 to 15, and we would like to work with the children of ADHD, and for gaming also we are planning to work with. These are the references.
Any questions from audience? It's already
Hello. Yeah. Please, any question from audience? You can. This is open interaction session. Anything related.
Is it consent form or concern form? Slide 24.
Consent.
If it's a mistake, fine, but you should be aware at least.
Consent.
How many times you would have seen the meeting? These three small mistakes. And throughout that, flexibility is difficult.
Question?
No, it's not a question, it's an observation.
No, no. They have
We have
question.
questions for them. Readability for the first row itself was little difficult. PPT font size should have been
Increase.
So can you hear me?
Yeah, yes.
So madam, you had said the emotions, they originate from the prefrontal cortex. So but from what we know from before it, I think the emotion centers are very deep down, starting from the amygdala and proceeding from there. So like, what made you come to the conclusion that the emotions are from the prefrontal cortex rather than from deeper down?
Yeah. Actually, I've gone through many papers, done references, and spoke to a lot of doctors. Actually, there are different parts for different emotions. So, front part is responsible for the emotion recognition. It's deep inside only. The brain, it is deep inside only, but the frontal part. In the back, it is for sensory organs like smell, vision, memory, all comes in the behind. But in the front part, it develops or produces the emotion.
For the first objective, you have collected 35 datasets from hospitals.
Yes, ma'am.
Okay, which hospital was it? Because your ethical clearance is from one hospital, but then the dataset is from another hospital.
Actually, ma'am, I've collected the data. Actually, I've been trying for ethical for a long time, but I was not able to get the clearance. But I got the data from the doctor. Then I got a clearance in the
In a different hospital.
different hospital.
Oh, but the data from SIMS, right? Even I had that question.
No, ma'am, data is not from the doctor. He is from SRM. He had his
35, as you call them as subjects, 35 subjects you mentioned.
yes.
So, are they from SIMS hospital?
No, ma'am, no, ma'am. Actually, I tried from SIMS.
Where from are they then?
Ma'am, actually, it is a private clinic, private hospital. The doctor, he was having a private hospital. From him, I got the data, but I could not get the ethical
Are they
clearance.
connected with Panimalan then?
No, ma'am. I've just they have an ethical clearance committee there. I've approached them. They were very nice and kind to give the clearance. the help of Dr. Rajeswari Immanuel. She was helping me out with the clearance. I
Once you
tried
get
with the
ethical
Sims.
clearance, it means that you have to collect the data or you have to get your data validated by that hospital.
Yes.
Did you show any part of your data to that hospital to get it cleared?
Actually we have an interview to clear the ethical committee. I showed my data to them and they are fine. They are happy with the data. They just check whether it is ethically correct or you are not harming any of your subjects. That's how they check and they said your data is good and clear. You are good to go.
So that objective of ethical clearance you have to mention somewhere.
Okay.
Why you have gone for ethical clearance?
Ma'am, actually my DC members and my during my even pre-talk people ask me for the ethical clearance and I have been trying it for years.
My question is, having taken the data from somewhere else,
Yes, ma'am.
getting it from the ethical clearance from somewhere else, is it ethically correct?
Actually, data, it's not you take the data there only you have to get a clearance.
It sounds bit data.
Actually, ma'am, getting ethical clearance was a bit difficult for me. I was trying from Sims also, I could not get it. So I've been trying and trying. By God's grace, I got it from Animal College.
One slide you have mentioned p-value is less than 0.05.
Yes.
So in that case, will you accept the null hypothesis or reject it?
Ma'am, if the p value is greater than 0.05, the null value is accepted. If the p value is less than 0.05, it is rejected. That means there is a significant difference in the classification.
I think in both the places you have given it as rejected. Just check.
Okay.
That slide.
Okay.
Actually, you shown two tabulation with alpha beta, na?
Yes, ma'am.
In that, you are actually concluding with some final statement on whether stressed or not stressed. Right?
Yes, sir.
And then you showed it to a doctor,
Yes, sir.
and he had sort of some kind of a disparity, like he has 95% something.
Ma'am, usually
What
neural.
way it differ?
Ma'am, usually neural network or any model cannot give 100% accuracy. There will be one or two slide.
No, doctor gave some clearance. Out of my manual, this is working on the data, he just told like.
Yes, ma'am.
This,
Yes, ma'am. Like the system has predicted to be stressed, but he says unstressed. So that's how there is a big difference, and that's how the model is 95%.
People used to show consolidated publication. Shown them. Consolidated list of publications.
Yeah.
How many years?
Ma'am, I have two scopus. One is here published, one is in pre-press.
One essay published.
Published and one is in pre-press.
You said 95% accuracy, but in your concluding remark, you showed only maximum 85, right?
Ma'am, that is for the accuracy second, objective of second one. Third one, it is 95%.
Concluding slide, nowhere you mentioned as 95.
I did.
Well, one question. So you said that you are going to collect the data during the morning sessions. Is
Yes.
there any specific reason for that?
Yes. Actually, during afternoon or evening, after the post-lunch, people will be drowsy, and in the evening they may be tired. So collecting the data in the daytime, like 10 to 12, they would be active, and we also check that whether they had a good sleep in the night. In the consent form, we collect everything, and then only we take the data of them.
Okay, was it suggested by any doctor or is it?
Yes. To get the higher good quality of EEG recording, the doctor, when I collected the data, the doctor was with me with the EEG technician.
But usually stress will be in the evening.
That was my doubt.
Questions from audience will come. Any questions? Audience side? Your title slide. Did you justify resilience word in your title?
Resilience, by identifying the stress, we can advise them to take good sleep and improve their.
You did only classification reduction. Where is that title?
Yeah, we can.
Justification is something. Right. And EEG network or EEG network or signal?
EEG signal, ma'am, but these EEG, using EEG, there's a network.
No. You are using one signals, that network is different, no? Yeah. So the title itself, so many controversies. Check through it, right?
Okay.
And then stress signal is continuous or discrete?
Stress signal
You are
is.
evaluating through signals. Maybe you can have in EEG signals. Stress signals are continuous or discrete?
It is continuous.
Continuous. Are you sure? Suppose in morning I been stressed and after some time I may not be stressed. I never forget that. That time the signal will be there or not.
Ma'am, actually, when we record the EEG, that time if you are stressed or not, that only we are calculating. So we are playing.
Discreetly continuous.
Professor, you should not help Professor. that is all the prerequisite of doing this research, right? Whether I should know the signal, when I will get stressed signals, right?
Actually, we
Signals
play
produced.
the video stimuli for them. We play happy videos and we play the sad videos. When they see.
No, that's not how we can identify on seeing a video a person may be stressed or not, right? It doesn't know. We are modeling ourselves. How it will support you for people around, variations are there.
When they are very stressed, the emotion will be more actually. So we can identify.
Emotions you can have it through videos, but stress how can derive from that? That's my question.
Ma'am, if they are very stressed, the emotion will be more.
It depends on the nature of videos.
Yes.
If I watch a Rajinikanth movie, I will get more stress.
That's why I said watching the movie is just how you can conclude that I am
Ma'am,
stressed.
this is just model we are understanding. With this we can use it to develop it more better so that we can use it in the institution.
So did you not develop better?
Ma'am, yes, I did develop it.
Oh, this is-
I think in that case, you are showing the same video for all 35 subjects, right?
Yes.
Professor is trying to clear out, right? The comparison of those 35, some ones are have high peak signals, then we can identify, but you are classifying as stress, not trust, right? That is not done, Professor. Okay, and then there is no abbreviations you are explaining. Anyone know LSTM, everything? All our CSC people are here. There is no explanation what it is, right? How it is working. At least in a few sentences you should add, what mechanism it is. It is not the way you dressed and the way you present exactly match. It's like industry, but it is academic now. There should be an algorithm explanations to RC or belongs to CSC. Right, there is no algorithm related talks, right? Only performance measures and the architectures are not clear, right? So those are the things we can do.
You are
Easy.
EMC, right? Electronics and Communication. Right?
No.
CSC.
But both the DC members are from EC, that also we know. Right? How come this? Yeah, that's why.
EEG signals.
That's the things, and double banana and 24th slide, I am skipping some more slides. 24th slide, double banana, some more methods I have seen, but you are not given explanation. Can you give an explanation for
Yes,
them?
ma'am, it is actually placement of.
24th slide, it is it 24? Okay, previous other thing, next slide, double banana, some more, yeah, right, 23.
Ma'am, actually the placement of roads. So they call it technically it is double banana method. So there are different montages for placing the sensors. So one of the method is double banana method.
Still you are not explaining what it is, okay? Okay, fine, 29th slide. Yeah. Is there any explanation for that free processing? What it is doing? Did you explain that?
Actually, every subject's data is collected and it is each subject data has been given as an input and 14
Here
channels.
also you are going for extract 40 channels of EEG. Like that the flow has to, if you are putting the diagram, you have to explain the flow. What purpose then that slide is? Right? Those are the things are not there. What is the threshold? What is I equal to 15? What is 41? Those are the things.
40 slides are there. So 40 videos are there. 41, if it turns to be 41, it will come out of it. So
This is for playing in a video.
no, ma'am. It is pre-processing. Means it is taking one after the other for pre-processing.
Pre-processing of what?
The EEG signal.
I am not able to understand what type of pre-processing is done on your.
Sir, band pass filter and Z-score normalizations.
And usually, whenever we are going for, we'll do pre-processing, feature selection, feature extraction, and then we'll go for an ad. It is in reverse order, I think so. Anything you can go for it, right? But it should be in order. No? But obviously, when you are seeking objectives, when you are going for a feature extraction or a feature selection, the accuracy will improve or not. Then what you are doing?
We first extract the features.
Obviously, with all the features you are going for and select a feature which will improve the performance, surely go for improving accuracy.
Yes.
And what you are trying to prove that. And it is in the process to what you are going for it, right? Whether you are going to detect it, it is in the pre-processing one step. Obviously, it should be right. So that you can have in pre-processing. And where is the novelty part of your research? What new you did it?
There's a enhanced feature selection method.
Enhanced method. What you did it in that?
We have combined PC and LTA to obtain a new feature, and it is that gives a.
Can you please go to the slide? Where it is? No, where you had did it, that explanation, not in the objective, we didn't see it. Where it is explained, novelty part.
Novelty is
In which method it was?
Feature. That slide you said like you're extracting a new feature. Is there any such I'm asking you.
Where it is? What is the novelty work? Where you have to put it in your slide, not in the objective slide. That method.
not objective. Go to the objective. Second objective. Move on. Go.
Okay. You explain that what is your novelty part.
Now we are combining the LSTM, PC and LDA together to obtain the new.
What is LDA? What is thing? Please, can you please explain it so that we can understand clearly?
Principal component analysis, and LDA is linear discriminant analysis.
So both the methods are existing already, right?
Yes,
Okay, fine.
the values from the PCA is obtained and it is given to the LDA, and it is combined together to develop a new set of variables, and 100%, top 100 variables are, features are taken and then given as an input to the model.
So this is your novelty part.
Ma'am, real-time data collection is really a big task because collecting people and
Yeah, we do agree you did a tremendous work, but your belongs to CSI. Again, I am telling that your belongs to a computer science people. We should work on algorithms complexity. That part is more important. I am not denying that your hardship is tremendous, but we have to draw more care about how we are processing the data, no? Not the collecting the data. Right, for collecting, anyone can do it, any neurosuggestions or all the people, but doing complexity, who are the people available? We are only people are work on program and algorithm side. Right, that you should take care of. And then this one, you go to the architecture, using feature selection, right? And then go to next architecture. Feature selection, here, right? Next slide. Next. Somewhere else, you are used to feature extraction in the diagram again. Maybe other side. Next. Architecture of that. Wait.
Next.
Doctor diagram, no? Here again, where is the thing? Feature extraction. After that, you are going for a TEG model. There you are going to use feature selection again.
Yes.
Feature extraction. After that, you are going for feature selection. Is that in the right way?
Ma'am, actually, from the EEG signal, 5 different features are selected, ma'am. So with that, totally 420 features are selected, and then it is given to the feature selection, which is more.
Can you please elaborate what is feature extraction, feature selection?
Feature selection is where you select a particular, feature relevant to the model, and feature extraction is what we extract feature.
So these are the main areas you worked on. You are claiming that you are contributed for extraction. So the fundamental difference you should know, it is not in order, I think so. And you put multi-class, so you have only 3 classes and claiming that multi-classes. Can you refine that what are the variants you will have SAD and in between? Those are the things clearly we should go for classification, right? Slide number 52. Yeah. So how it is classifying? It is any parameter related to happiness or sad. Another thing we are not visible. What is that in between yellow?
Neutral.
Is that in a class?
Neutral emotion is.
It is not in the category. In the category, that category, shall I claim that as in a multi-class?
No, ma'am. It is.
What is meant by multi-class?
Multi-class where if it is not binary class, then when we classify more than 2 classes, then it is multi-class.
Is that right? We have only 2 emotions, or you took 2 emotions?
No, ma'am. It is neutral is also like when we consider the EEG signal, when the person is stressed, the emotion sad is given, or like he is stressed and
Stress is equal to sad. Stress is equal to sad.
No, ma'am.
The parameters, how it is varying from happy to sad, those things you have to explain. No, in
P-value
algorithm.
is calculated.
What is the value? What is the range? Where you have specified within this range, it's called as happy. Within this range, it is called as sad. Did you have in your presentation?
Ma'am, I just explained how p-value is calculated for different emotions.
No. For this happy, what is the range? I am asking
The
about
range
that.
is 0 to 3, ma'am, 0.3.
Where it is specified in your presentation?
Yes, ma'am. Go to the objective 3.
But it is an objective too, no? How you can match that? Right? This is also you have 5, then you know there is a happiness is there, share is there, it's 5 plus multi plus, right? You had mentioned there this thing.
Yes, ma'am, that is subjective too.
I hope you can understand what I mean, right? We'll leave for the next thing. And then, yes, of course, feature selection, any classification you should go for pre-processing, feature selection, feature extraction, and then classification. This is an order. Whatever the algorithm you are performing, in this order only you should perform. It is in reverse order. And then diagrams are not clear, even 69 we are not able to visible. And more features, obviously more accuracy will come. And results images are white image you are putting. The results are done by you only, 77. 77. Can you go for 77? These are the results you got by yourself, right?
Yes.
For clearance you are going for images or a thing, right? Why you are cutting and pasting?
I'm used to pieces, so I place it.
No, it is not a thing, right? And you should cite it where you have got it if you are putting an image, right? This is not your results. In you, if you are putting as in tables, it's
No,
in
it's
research.
fine only.
Then you have a Word document also, no?
Yes,
You should
ma'am,
place
I
it.
have.
Okay, you would place it. It's more clear, more accurate, right? And then summary, 79. What is the difference between your conclusion and research contribution? 2 slides you will have. What is the difference, right? 2 slides you have put it for research contribution. and
Conclusion is
conclusion.
conclusion of objective 1, 2, 3. The contribution is what I did.
Okay. So all the things require data, right? If you are working in like a data scientist, all the data should have ranges. This is a thing for the 6 value for this I had put like that. Is okay. Whether it is good. Sir?
Rajeswari.
Sir.
Yeah, madam, whatever the observations I have made in the comments, okay, forget about small references, etc. Anyway, you are corrected, I suppose.
Yes.
But otherwise, my thing is only, I am not electronics man. I understand. You are also not electronics man.
Yes.
I thought you were electronics man. Yes. But this 35 data, for me it is a data, subjects.
Yes.
Right? It looks, it is
Less.
very less.
Actually, sir,
But you have written that each data is very big. It is not a matter. For you, what data is, what data.
right.
Sample. Whether 35 data is there, of course I understand it's very difficult to get the data, especially in medical field. You have spent most of the time in collecting the data, relevant data. That is very appreciated. Instead of just downloading the data from UCA, you'll be trying 1 lakh data and then apply some LSDM or whatever. But here getting the data, it was difficult, I understand that. But even then, the number of data, I felt, why this is is not available in any of the open source.
It's available, 2 data sets already there.
That is also very less. 15
Yes,
or,
actually all the data set, they are in less numbers, like 12, 15, 20, because one person's data is only takes, if you capture for 1 minute, it takes bigger size.
Come to, of course, to ask the time of your signal when you are recording or when you are getting the signal, it is 10 to 12 doctors suggested or something like that. I think it is not only doctors, they have suggested 5. I think it depends on other parameters also. It depends on not only the time, It depends on where the place also, where the fellow is, right? His atmosphere and with whom he is interacting. I think all those things are also the same person. Sometimes he may be very much stressful, sometimes he may be neutral. Okay, so I guess class. I mean, getting the data. Very. I don't know. But anyway, it's you have tried something. Okay, fine. Now I come to computer science. You have applied some LSTM or whatever. Okay. Somewhere I have seen you have gone up to 150 above and then optimum we have got it around 75 in first objective, 80 in the right. Actually, it will take a lot of time, right?
Yes.
It is a book, it will take a lot of time.
Yes.
Sometimes overfitting, all those problems also. So what is meant by optimum? You have stopped at 75. What is meant by that?
So actually, when we keep on increasing the epoch size, the time is also increasing. One point of time, the accuracy stops. Like it keeps coming the same. And even if you keep on increasing the parameter one.
Only Sarah is asking, what is that one point? Where you stop? That is asking. That is easy.
I got maximum accuracy at that point. Afterwards it started dropping, so I picked up the point.
Yes.
Is it so? I just asked.
Yes.
Okay. I think the objective one you said only binary, right?
Yes, sir.
Stress or not?
Yes. If there is any change in the wavelength, like peaks, when the peaks are very high, then it is identified it is stress.
You already said that.
Yes, if it is a normal waves, or there is no peaks in the waves, then it is identified to non-stress or unstress.
When they are taking this is medically I am trying to understand. When they are taking the signal for recording and whatever, you said that they will identify the place, double banana method. What it is?
Yes, yes.
It's what standard method?
Yes, yes.
By the doctor.
Yes, there are different montages available. For seizures, when you get fixed, they will put the electrodes or these sensors in different way. They even monitor you for days together. So for normal people of identifying the sleep or the stress or all those things, they have different montage, and those are applied. It's nothing but they place the sensors in the particular area, particular points. We have around 64 points in our head. So they identify those places and place it in the head, and with that we get the optimum result.
Now I have come to neither electronics nor computer science. Slide number 40.
49.
You know what I mean. Sorry if it is too much of mathematics. Sorry, I am from mathematics background, so I want to know whether you know what you have written there. Okay. Mean of absolute values. You, sir, I have taken this as a formula. Don't ask me physical interpretation and all. Then I won't ask. Now, just I want to know why this 1 by n minus 2 and all, you are going up to mean of absolute values of second difference n minus 2,
Yes.
third difference n minus 3,
Yes.
first difference n minus 1,
Yes.
mean 1 by n, 1 by n, mean. Just the standard deviation, what you have written, mean from the mean standard deviation, what you have written, there you have put 1 by n, right, inside the square root. Just to check whether. Okay, that is mathematically. I know. I'm not expecting any justification or answer for that. Generally, we 79. You are dealing with the samples, right?
Yes.
It was not 1 by n in the standard case. Okay, next. 79. How many 35?
35.
Huh?
What?
No, t-test and you operate is the third objective, right?
Yes, sir.
You know, this is number of data. How many?
Data for 35.
This is for the third objective.
Yes.
You have.
Sir, actually 5 features. So 5 features are compared between each other. So it is
by
10.
future comparison.
Yes, it's just feature comparison. So 5 features into pair. So it is 10 for each comparison, and t-test is conducted. If t is greater than 0.05, then null hypothesis is accepted, otherwise it is rejected. And statistic value gives higher, there's a difference.
What p-value you got?
So it's given here 2.38 power 10 power minus 11.
It is given there, but we are not able to see. This detail is just a basic doubt. Okay.
Yeah, that is what I
Yeah.
think you put it this way. If it is less than accepted, greater than rejected. That's what first madam asked, then I woke up.
And formula says x minus, my memory formula says t value is equal to x minus mu by s by mu z. Correct. Mu is the population mean estimated standard. So where is population mean mu coming?
Sample mean the notation is using the population.
Okay. But here in null hypothesis, it's just a comparison of those population mean.
Here actually we cannot know the population.
Yeah,
See, because in the literature somebody might have done like this, you also have tried. But again, these are some of the basics, whether it is applicable to our problem or whatever hypothesis we are taking. Right? Yeah, that's enough from the, somewhere the initial last one, again this is for my, I'm trying to understand. You have taken 3 different data set. I have seen one is 30 to 40, another one is 20 to 27, right? And the third one is some other age group. And you are, I think the comparing of this data set, which are of different age group, I don't think it is, because 20 to 27 fellow, that may not have any stress or full stress. If he is 90, if he is 90, he will be full stress. Okay, if he is having jobless, no problem, no stress. But 30 to 40, family stress or other stress will start that anyway. Right, just I'm trying to understand.
Actually, those two are the benchmark data.
Benchmark data.
Most of the reference papers use those data sets. So I also used it, but I wanted to work with the age group of 30 to 40, so I've just compared with them.
Yeah, otherwise it's fine. As I said, you have put a lot of effort and you have tried some new area, I can say, where probably not much of work. But as Madam pointed out, generally, as a computer science, we will concentrate more on the new algorithm. Okay, combined in the last objective, you combined something. So we always, because complexity only we will always concentrate, so new algorithm, etc. But again, when you are doing in the future, actually, when you are having a more number of data or something, when you are trying to apply some algorithm, you try to apply some new algorithm. So mixing of 2 or 3 algorithms. And that will be a novel. That's really novel. Okay.
Confusion matrix is nowhere presented.
Once last, somewhere she has presented. No, that is because confusion. Everyone will get confused. So that's why they won't present the confusion matrix. Fine. Otherwise, this the nature of the work and this is. We have got a good publications, good number of publications, and the Scopus also, and SCE also is seen some too. So standard publications you have got it, and that certifies the quality of your work. So I think you have already got one patent, right? So yeah, you got it, right? Or
Yes, sir, I got it.
You have got it, right? So continue the work.
Published, right? Not got it. No.
Publish, okay. Okay, so continue the work and do well. That's all from my side. Okay, thank you. Yeah, any other, suddenly somebody got enlightened and they wanted to ask. Okay. Yeah, if no other questions and no clarifications needed, Madam Rajeswari Immanuel, she has done wonderful work. And this is, I can say, one of the very, the presentation of the work, as an examiner I have gone through that, the presentation of the work is really good. Whenever we are not getting sleep, not stressful. Whenever we are not getting sleep, I used to read some theses. I couldn't get a single typographical or grammatical mistake in this thesis. Very rare. I took it as a ego problem. Then I realized who is her guide? Madam Sangeeta. Of course, I was the examiner for her long back. Probably I would have, she know where I will go through, where I will point out, and also she might have taken care, I think. So that's an excellent presentation of the work in the thesis from the organization presentation. Very good. And a good number of publications based on the work done by Madam Rajeswari Immanuel. And the successful presentation and defense of her work by her today. This panel recommends the award of PhD degree to Madam Rajeswari. Congratulations, Dr. Rajeswari.
Congratulations.
Congratulations on your book.
Thank you. I would like to thank everyone. First of all, I thank the Almighty Lord Jesus Christ for having blessings on me to complete this research work successfully. I thank our former Chancellor, Dr. T.R. Parivendra, Pro-Chancellor, Dr. P. Satyanarayan, and Pro-Chancellor Admission, Dr. Ravi Pachimuthu, Correspondent Ms. Harini Ravi, for providing this support and motivation. I express my sincere gratitude to our Vice Chancellor, Dr. C. Muthamil Chelvan, Registrar Dr. P. Ponusamy, Controller of Examination Dr. K. Gunasekaran, Dean Research Dr. B. Napoleon, Dean FET Padapalli, Dr. C. V. Jayakumar, Vice Principal Academics, Dr. C. Gomati ma'am, Head of the Department of Computer Science and Engineering, and DRCC Head, Dr. S. Prasanna Devi, Department Head, E-Tech, Dr. P. Chitra, Research Coordinator, Dr. K. Ramachandran, and other HODs, management, administrative authorities of SRM IST for providing the facility and environment to carry out my research. I would like to thank the management of SRM IST for allowing me to do my research in this esteemed institution. I express my sincere gratitude to my supervisor, Dr. SKB Sangeeta, Department of Computer Science and Engineering, who has supported me throughout my course with her patience and knowledge. I am thankful to her for her contribution of time, idea, support to make my PhD program that helped me to make the work more productive and stimulating. I am especially thankful to her for teaching me both research skills and writing skills. I value her concern and support all the time, which was motivating me throughout my PhD. I express my sincere gratitude to my doctoral committee member, Dr. V. Vaidyanathan, Assistant Professor, Department of ECE, NIT Delhi, and Dr. D. Sriram Kumar, Professor, Department of ECE, NIT Trichy, for their support, guidance, and timely suggestion for my course. I also extend my thanks to Dr. S. Arunan, the neurologist, Chief Civil Surgeon, Government Stanley Medical College Hospital for the collection of data, and I am also grateful to Panimallar Hospital College and Research Institute for giving the ethical committee clearance for the same. I also thank Dr. S. Prasanna Devi for her support for obtaining the ethical clearance. I am really grateful for the valuable suggestion given by the thesis correction that my foreign examiner, Dr. George Jinnah, Professor, Department of Computer Science, Brunel University, London, my Indian examiner, Dr. A. Kandaswamy, Professor, Department of Mathematical and Computational Science, NIT Karnataka, the expert member, Dr. G. Geeta, Associate Professor, Department of Information Science and Technology, Anna University, for their inputs. I express my heartfelt thanks to all my department friends, research scholars, colleagues, teaching and non-teaching faculty members, library staffs, ITKM staffs in the Department of Computer Science and Engineering, SRM IST, for their suggestions and support. I would like to express my heartfelt gratitude to my father, Mr. I. Balasubramanian, my husband, my pillar of support, Mr. Rajeswari Immanuel, the Powerpuff Girls, my daughters, Miss Janie Immanuel, Miss Jessica Immanuel, and Miss Joanna Immanuel, for the continuous support and motivation to finish my degree with excellence. I thank everyone for your presence in this special day of mine. Thank you, everyone.